trigonometry class. Welcome to the lesson today for 1.5. This will be dealing with right triangle trigonometry. And to begin with, what we want to look at is review just a few things that we learned previously, primarily the special triangles. So let's go over a few things on that to begin with. Okay, one of the things, of course, we learned about the 45-45 right triangle. It's important that you commit this to memory because we use it a lot. So the sides are 1, 1, square root of 2 is what we learned. And that's very logical. The sides opposite equal angles in any triangle are always going to be the same. Okay, the other triangle that we learned something about was the 30-60 triangle. So we would have a 30-degree angle, we'd have a 60-degree angle, and a 90-degree angle. This is the one that I always refer to as being easy as 1, 2, 3. Well, really it's as easy as 1, 2 square root of 3. So it goes like this. The smallest side is 1, so it goes opposite the smallest angle. The square root of 3 is actually about 1.7, so it is the middle side, so that's going to go there. And then 2 is the biggest side, so it's going to go opposite the biggest angle. So just a little basic geometry on that. Okay, one thing that we learned a little bit about was quadrantal angles. Now you want to remember that quadrantal angles are angles that are on an axis. 0 degrees, 90, 180, 270, 360, and so forth. So let's just start by looking at a 0-degree angle, which of course would just be the positive x-axis. So one of the things you want to remember is if you got a unit circle, you're going to have a point 1, 0, okay? Because basically the radius of this circle and a unit circle, for simplicity, we're just going to say that r is equal to 1. And when you're finding the values of trig functions, it all depends on whether or not you can find the value of x, y, and r. So since we're letting r be 1, well, x is also going to be 1, and y is going to be 0. So notice in this point, you have x and you have y like that. So that's going to give you the key values that you need for a 0-degree angle. Okay, now if you looked at a 90-degree angle, clockwise from there to there, you would be on the positive y-axis, which would give you the point 0, 1. And then that would mean x would be equal to 0. That's the x value. Y would be equal to 1. That's your y value. And of course, r, we let that equal to 1 in a unit circle. So these would be the key values that would find the values of all 6 trigonometric functions. Okay, now if we went to 180 degrees, halfway around the circle we know is 180 degrees, so you would formulate a point -1, 0 on a unit circle, with x being -1 and y being 0. So at this angle, you would have x is -1, y is 0, and you would have r is 1 as we chose it. So those 3 values right there would give you the values that you need to find the values of the 6 trig functions. Then if you went to 270 degrees, okay, that would be like the negative y-axis, so you would create a point 0, -1, okay, with x being 0 and y being -1, so you'd have x equals 0, y equals -1, and you would have r equals 1. So that would create for you the key points that you need. Now, that kind of a thing, you need to be able to create that. You need to know your special triangles and have that memorized. You also need to be able to create the x, y, and r value at any of these quadrantal angles, because that'll help you to figure out the special values of trig functions then. Okay, so I'm going to move on a little bit more to the next page now. And what I'm going to look at a little bit here is we're actually going to look at statements now that are saying this. This statement right here, when it says cosine of alpha equals square root of 3 over 2, what we're doing is we're finding an angle. Remember, alpha represents an angle. So the idea with this is I've given you the ratio of the sides, okay? And remember, the cosine's definition we learned, is x over r. So in this particular problem, since the cosine is x over r, then we should be able to figure out which triangle that applies to then. Well, the triangle that this applies to is going to be the 30-60 right triangle, and the reason we know that is basically because of that square root of 3. So what I'm going to do is I'll have you just draw a triangle on this. So we're just going to draw a picture of the x and y axis, and we're going to draw out a special triangle on that. Okay, so when I do this, let's just go out. This is going to be like the radius. We're going to draw this straight down to the x-axis like that. Now, the cosine's x over r. That means I gave you x is square root of 3. So that will represent the base of that triangle. I gave you that the r value is 2, so that's going to represent the hypotenuse of that triangle. And then remember, we have a right triangle that has the sides 1, 2, square root of 3. So that means that this side is going to be 1 like that. So now what you got to do is just figure out the angle. So remember, 1 goes opposite 30, 2 goes opposite 90, and square root of 3 goes opposite 60 because they're put in numerical order. So that means the answer to this problem is going to be alpha is equal to 30 degrees. So what you're doing is you're doing this problem in reverse. You're taking a statement cosine alpha equals square root of 3 over 2. So I've really given you the ratio x over r since I'm asking for a cosine. And then you can work backwards to find the value of that angle. Okay, the next problem we're going to look at in a very similar way. So again, on this one, I've given you the sine of angle alpha is square root of 2 over 2. So what we're trying to do now, see, is we're trying to find an angle alpha. All right, so what you see on this is since you have that square root of 2, anytime you have that square root of 2, the triangle that goes along with that is the 45-45 right triangle. And we also know that the definition of the sine is y over r. So what that means is, in this problem, is I gave you that y is square root of 2, and I've given you that r is 2, like that. Now, one of the things you'll kind of notice on this is if you were to look at the special triangle that we learned, if you have a 45-45 right triangle, the sides went 1, 1, square root of 2. Okay? So the thing is, this doesn't really match up with what we have. Now, there's another thing that you can do on this if you want to, is you could just take this expression right here and you could rationalize the numerator, and that would make it match up with this triangle a little bit better. So what I'm going to do is multiply by square root of 2 over square root of 2, and that's going to give, hold on, I think I wrote that down wrong, didn't I? Let me erase that and fix that. Sorry about that. Okay, so let me erase that and write that a little bit cleaner here. Okay, so what I'm going to do is let's take this expression, square root of 2 over 2, and let's rationalize that numerator. So I'm going to multiply by square root of 2 over square root of 2. That's going to give 2 over 2 root 2, with the 2's crossing out, leaving you 1 over square root of 2. So if we look at it this way, y is 1, and then r is square root of 2. So that's more what we're used to seeing in the triangle that we learned about, is we're used to seeing a 45-45 with the sides opposite 45 being 1s, and the side opposite right angle being that. Okay? So then what you would have on this is, if you were looking at this and kind of superimposing this in a graphing system on an XY coordinate system, then it would look like this. So what I'm going to do is take and just draw this angle. So I'll draw that triangle, right? Then if I go straight down the x-axis, I've got a 45-45 right triangle, and the sides are x equals 1, y equals 1, and then r is equal to square root of 2. So that means that if we're looking at y over r, okay, then we're going to be looking at a 45-degree angle, because I gave you that the sine is equal to 1 over square root of 2 like that. Okay, so that means the final answer to this problem now is going to be that alpha is equal to 45 degrees. Sometimes it's handy to go through and rationalize numerators when you're doing this then. Okay, so that's how that goes. I'm going to look at maybe one other illustration of this. And again, you're trying to work backwards to help you to figure out the value of this angle then. Okay, so next thing I want to go through and do on this one is I've given you the statement tangent alpha equals 1. So again, what we're going to be doing on this is we're going to be finding the angle alpha. So let's reason it out this way. We have the tangent of alpha equals 1. Now a trigonometric value is always a ratio, so it's logical to put that over 1, and then you want to remember that the definition of the tangent is y over x. Okay, so that will help us to figure that out. Well, the triangle that has two 1s in it, again, is going to be the 45-45 right triangle. Again, you know that because of those two 1s. So if we were going to go through and draw ourselves a diagram, okay, here's the x-axis, here's the y-axis. So if I wanted to go through and just superimpose this triangle on the coordinate system, it would go basically like this. Again, you would draw straight down to the x-axis, and you would have a 45-45 right triangle, and the sides on this went like this. 1, which would be the x value, 1, which would be the y value, and then r would be square root of 2. Okay, so that means if the tangent is y over x, and it's 1 over 1, then that would correspond to that angle right there, so you would have a 45-degree angle as its answer. So again, if you're doing tangent of 45 degrees, what are you doing? You're doing y over x. Well, if you look at my diagram on this, y is 1, x is 1, so I got the tangents equal to 1, and of course that matches up what I gave you then. Okay, so that's the idea. So what I'm going to do is I'm going to pause this just for a few minutes, and I'm going to let you all go on and try to do these next two problems, number 4 and 5, on the next page. And this is a Camtasia recording, so the best thing to do is just go ahead and pause it right now. And when you pause, all right, I'm going to resume the recording, and let's see if we did this okay. So this is actually pretty similar to the problem that I did a few minutes ago. Now, first of all, I'm giving you the cosine of alpha equals square root of 3 over 2. So what you're looking for is the angle alpha. Now the definition of the cosine we know is x over r. So that means in this problem, x is represented by the square root of 2, and r is going to be represented by 2. Okay. However, if you look at a triangle, it matches up a little bit better this way. So the triangle that we've been working with that has a square root of 2 in it is the 45-45 right triangle. Goes like this. Sides are 1, 1, square root of 2. So it actually makes a lot of sense on this, since we're looking for x's radical 2. And notice here I've got x is 1. Well, let's rationalize the denominator. Okay, so I'm going to multiply by square root of 2 over square root of 2. That's going to give 2 over 2 root 2. The 2's cross out, leaving 1 over radical 2. So it's a little bit more logical to do it this way then. Okay, so the triangle that replies to this, again, that you should have figured out, is it's the 45-45 right triangle. And then if I was to go through and draw a picture on this, then it's going to go basically like this. So I'm going to go ahead and get this triangle drawn on this. So I'm in quadrant 1. I go straight down to the x-axis. So what I have is x equals 1, y equals 1, r equals square root of 2. Your job is to find this angle alpha. So that's going to be 45 degrees. So the answer you should have got on this problem was 45 degrees. Again, you're looking backwards at that problem. Okay, the second problem I gave that the sine is equal to 0.5. So really, in this kind of situation, if you have the sine of alpha is equal to 0.5, well, you got to know that that's a half. Now, the definition of the sine is y over r, so that means in this problem, I've given you y as 1, and I've given you r as 2. The triangle that's going to correspond to now is radius of 2, y value of 1, x value of square root of 3. So when I draw a picture on this, we're going to be looking at the 30-60 right triangle this time, and it's going to go more like this. Okay, so as I put this together now, let's draw a rough picture on this then. So we're going to go out like that. Again, we always draw this thing we call a reference triangle down to the x-axis. So what we're going to have is r equals 2, y equals 1, and then we're going to have x equals square root of 3. Okay, like that. Now again, how do I know where to put things? Well, because the y value, see, I gave you the y values 1 because I gave you a sine. So you do that, and then the angles go 30, 60 like that. So that means the answer to this problem is alpha is going to be equal to 30 degrees. Okay, so again, I'm giving you the ratio of x, y, and r. I'm giving you two of those variables. That's enough to figure out which one of those special triangles you belong to then. Okay, the next thing I want to do, and this is a very, very abstract thing that oftentimes kind of bothers students at this level. I can't really technically explain all the intricacies of what an inverse trigonometric function means yet, but typically in college algebra classes you learn about inverses. So first of all, I just want to talk about the language behind this. Okay, that is the inverse sine of x, and what it's doing is it's giving you a value of alpha. It's giving you an angle alpha. So it really means this thing, okay? It means the sine of alpha equals x. So see, notice what I've done on this, and the way this works in an inverse trig function is I'm really giving you the ratio of the side, but what you're doing is you're finding the value of the angle. Now, the thing that I can't really clearly explain until we get into graphing is this thing right here, is what we mean by that interval. So the idea is whenever you're doing an inverse trig function, an inverse sine, your answer can only fall on that interval from negative 90 to 90. It has a lot to do with you can only have an inverse function if you are inverting a one-to-one function. And we'll learn a little bit about that as we get into the details of the graphing. So right now, mainly what I'm trying to do is just get you comfortable with the language. If you're asked for an inverse cosine, that's what that -1 symbol means, then you're finding the angle alpha. Now, an inverse cosine is going to be defined on this interval. So if I'm asking you to give me a value of an inverse cosine, what's incredibly important is that you only give me the answer from 0 to 180. So it's impossible. If you did like the inverse cosine of some number, you will never get something like 181 degrees because it's out of range. Okay? Or you would never get like an inverse sine. If you did an inverse sine of something, you're never going to give me the answer 95 degrees because it's out of the range. So you have to be within that range. Okay? And then we have the inverse tangent. Okay, which just basically means you're finding the angle alpha. And again, what am I doing? I'm giving you really the ratio of y over x in that problem. And then what happens on this is an inverse tangent can only be on that interval. Now, this is an open interval. The reason being because the tangent of 90 degrees is undefined, so you have to have like that. So the idea is if I ask you for an inverse tangent of some value, you would never get 90. You can't do, that's not defined, or you could not get like 96 degrees. You can't be outside of that range. And again, we'll get to that point a little bit later as we get to talking about graphing. Okay, so the next thing I want to begin to look at here is just the terminology, and then we'll work on a few issues here. Okay, so this is saying inverse sine of x equals alpha. So remember, if I'm finding an inverse sine, you are finding an angle alpha such that the sine of that angle alpha is equal to x. X can be like the ratio of the two sides of y over r. And then if I'm asking for an inverse cosine of something, what that means, sometimes that thing kind of jumps around on me on this walking thing that I'm using here. So again, what we get is this really means this. This means that, come on, stop that, behave. Okay, it means if I'm asking for an inverse cosine, it means that you're finding an angle alpha such the cosine of that angle alpha is going to be equal to x. Okay, so what I'm going to do now is we're going to look at, solving a few problems like this next. Okay, so we're going to look at, on this number 6, I'm asking you for the inverse sine of the square root of 3 over 2. Now what this means, and this is kind of an important thing to look at, the first thing that you need to know when you see this symbolism is you need to know that you're finding an angle alpha. Okay, you need to find the value of that angle. And since the definition of the sine is y over r, I've really given you the parts of one of those special triangles. Okay, one thing that's real important on these, if I'm asking you for an inverse sine, the first thing that you ought to do is you should say, okay, I'm only allowed to give an answer on the closed interval negative 90 degrees to 90 degrees. Now, if you're talking about radians, that would be from negative pi over 2 radians to pi over 2 radians. Okay, so what we do on this is we just kind of interpret what kind of special triangle we have on this. So I'm going to draw a picture on this, and it's going to go basically like this. So let's just say that we have a radius out here somewhere. You get some point. They're going to go straight down like this. Okay, so the idea is I gave you y, so that means that y value is the square root of 3. I gave you r, that's a part of what you're given, so the radius is 2. Now that goes along with the 30, 60 right triangle. So remember it this way, the 1 goes opposite the smallest angle, 30. The square root of 3 goes opposite the middle angle, 60. And then you got the 90-degree angle. So what you'd find on this is the answer to this problem is 60 degrees. Okay? If you wrote that in radians, if you multiplied that pi over 180, then you would get, that reduces down to pi over 3. So the answer in degrees is 60. The answer in radians is pi over 3. So again, what you're doing is you're just working with that backwards and finding that angle. Okay, now let's go on. Let's do some other examples. This tends to be sometimes a little bit problematic for some students when they're learning that. It's pretty abstract. But the idea with this is, as you're doing these problems again, what you want to get real comfortable with is these basic fundamental ideas. First of all, if I give you this statement, inverse cosine, it means that you're finding an angle alpha such that the cosine of that angle alpha is square root of 3 over 2. Okay? The definition of the cosine is x over r. So in a sense, I've given you an x value and an r value, and that's going to go along with one of the special triangles. Now, if you're dealing with a inverse cosine, then your answer in degrees can only fall from 0 to 180. That's by definition of the inverse cosine, so you got to know that. Or in terms of radians, that's going from 0 to pi, like that. Okay? So the idea with this is going to be that if we went through and just drew a picture of this, okay, well, we have an x value that's square root of 3 over 2, so x is square root of 3 over 2. So what we're going to do is we're going to draw this kind of like this in this quadrant. So, all right, so we're in quadrant 1, so I'm going to go kind of like that. I don't know what I just did there. Come on, behave. Okay, so what I'm going to do here is draw, again, a diagram like this. Draw a triangle. Okay, again, I gave you x. X is a positive value, so you're going to the right, so that's x is square root of 3 over square root of 3. I gave you r. That's the radius. That's the hypotenuse of the triangle, so that means y is equal to 1. So your job is to find what this angle alpha right there is. You're always looking at that angle from the x-axis to the radius. So again, the angles go 30, 60, with the 30 being opposite the smallest side. So that means the answer to this problem is also going to be 30 degrees. Okay? Now, what I'm going to do is I'm going to erase what I just did. So if you need to get this copied down, you can go ahead and pause my presentation right now if you want to. And then what we're going to do from here is I'm going to go ahead and change this problem slightly. So I'm going to go ahead and just erase all of this stuff and start over again. because I need to show you what happens if you're dealing with a negative value. Okay, so I'm going to change this problem just very slightly here. And we're going to look at, instead, we're going to look at the problem inverse cosine -1. This time we're going to look at negative square root of 3 over 2. So that changes things a little bit. Okay, so the idea is the answer to an inverse cosine is going to be from 0 to 180 degrees, or if you prefer in radians, 0 to pi radians. Okay, so if we go through and draw this value then, see what we've got is we've really got negative square root of 3 over 2, with r being 2. Remember, r is always positive, and then we have x is negative square root of 3 over 2 like that. So what that's going to mean, if we draw a diagram on this, okay, it now means that our x is going to be to the left because it's a negative value. So what we're going to end up having is we're going to draw our reference triangle over into quadrant 2 like that. Okay, now notice on this time I gave you x is negative square root of 3, negative square root of 3. I've given you r is 2. So that means y, based on our knowledge of the triangle, is going to be 1, and it's a positive 1 since you're going up. So what your job is to find that angle alpha right there, okay? Now you have to be in this quadrant because your answer to an inverse cosine is only between 0 and 180. You can't be anywhere else, okay? If I ask you for an inverse cosine, you're either in quadrant 1 or you're in quadrant 2. You can't be anywhere else, okay? So what you'd find is this would be a 30-degree reference angle. That would be a 60-degree angle. So then that angle alpha would just be 180 less the 30, so it would be a 150-degree angle. So that means the answer to the problem in this case would be 150 degrees. Okay, and then that's how that would get put together. So that's kind of tricky on there, is if you have a cosine of a negative value, you're in a little bit different place now. Okay? All right, now let me do this next one. And as we do this next one, again, we want to pay real close attention to certain things, and particularly what quadrant we're going to be in and so forth like this. Okay, so what we need to do from here is let's just kind of draw down. Let's write down the definition of this. Okay, so what I've given you again is I've given you the inverse cosecant of -2, and I'm going to go ahead and put that over 1. And the definition of an inverse cosecant is r over y. So really in this problem, you got to look at it the correct way. R is positive. So really the y is what's negative. That's how you reason that out. So you got to think about that sign. R is always positive. Okay? So if we go through and do this now, an inverse cosecant is defined to be on the interval. And it's going to be just like the sine. It's going to be, although it's going to be from negative pi over 2 to pi over 2, or if you want to look in degrees, that would be from negative 90 degrees to 90 degrees like that. Okay. Now the problem is if you do the cosecant of 90, I want to show you something on this, just kind of at the side. So if we were at the point, come on, why does it do that? If I was at the point 0, 1, like that, okay, that y is 1, r is also 1, like that. If you wanted to do an inverse cosine, you would not have any problem with that, but you're going to end up having a place where the inverse cosecant is going to be undefined. So if you looked at the point 1, 0, no, write it that way, Brad, 1, 0, okay, what you would have on this is r would be 1, y would be 0, so that means the inverse cosecant is undefined at 0. So what we actually do is we write our interval not this way, but we write our interval as negative pi over 2 to 0 union 0 to pi over 2 like that. Now that's something that you just have to kind of memorize, and again this will make a little bit more sense when we get a little bit later in the class when we start graphing. So basically this means this: if you're going to draw a diagram to figure out this angle, well, first of all, if y is negative 1, then you have to be going down like this then, Okay, so I'm going to just draw a picture kind of like this. Okay, so what's happening on this is if y is -1, it can't be out in a quadrant. It actually has to be straight down like this. Just you got to think about this a little bit. This is a quadrantal angle, so it's going to go like that. Okay, the only place on a graph where the y value could be -1 would be down at this angle, which would be 270 degrees. Okay, like that. Okay, so what we'd end up having is we'd have y is -1, we'd have r is 1, so we would be at 270, but 270 does not fall in this range here, so you have to say -90 degrees, or you have to say -pi/2, because you have to make sure that your answers fall within the specified domain. Okay, so that's a real important thing. 270 is outside of that range of answers. That's why you have to stop it and use -90 as an answer. All right, so what I'd like you all to do is try the next two problems. So on this recording, it's a good idea right now to go ahead and just pause it, and then you can resume it as soon as you're done with problems 9 and 10. Okay, so let's see if we reason these out okay. And the very first thing that you want to consider when you're doing these problems, now this one you're doing an inverse sine. So right away what you want to do is think about, okay, where can my answer fall between? So in terms of degrees, your answer can only fall from -90 to 90 degrees. So you cannot give me an answer outside of that range. If you're given a radian answer, your answer must be within -pi/2 to pi/2. It cannot be outside of that. So the next thing to consider is you could think of this as what this statement really means is it really means the sine of alpha is equal to -1. You're trying to find that angle alpha, so I'm going to put that over 1. So that's going to say that y is -1 and r is 1 because that's the definition of the sine. So the only place that that occurs, there's only one place where that occur on a graph, and where that would occur would be down here. Okay, so you would have to be down at this point right here, like this, and that would be the point 0, -1. So y would be -1, and see r is just this radius right there. You kind of got a circle going around that like that. Okay, so that would mean that you got two choices here. You could say, okay, that's a 270 degree angle. Come on, stop that. 270 degree angle. Or if you go clockwise, that would be a -90 degree angle. So actually, you cannot say 270 because that's out of the range. So the answer to this problem in degrees would be -90 degrees. In terms of radians, the answer to this problem would be -pi/2. So that's how you have to reason that out. There's not much work to show on your paper, but there is a little thought process that's going on that problem. Okay, the next problem, what I'm going to look at on this is the meaning of this problem now is that if you were to take the tangent of alpha, and in that angle alpha, you would get the square root of 3/3. Okay, now one of the things you're going to find, if you look at the two triangles that we learned, these problems are designed so that they're going to these triangles. A 45-45 right triangle has sides 1, 1, square root of 2. So this problem is not going to have anything to do with that triangle because there's a square root of 3 there. And then the definition of the tangent is y over x. Now if you look at the other triangle, a 30-60 right triangle, that basically goes like this. You've got 1, 2, square root of 3. So it looks like that this is definitely going to go to this because this triangle's got a square root of 3 in it. Okay? So what we're going to do is that, but you also got to notice on this, if you kind of look at this and pay attention to this, well, I've got a square root of 3, and I've got that in the triangle, but I have a 3. There is no 3 in this triangle. So anytime you encounter this, it's oftentimes a real good idea to just go through and rationalize your numerator. So that's what I'm going to do over here. So I'm going to take the square root of 3/3, and I'm going to rationalize that numerator. So I'm going to do this. So when I do that, I've got 3 in the numerator. I've got 3 root 3 in the denominator. That's going to cross those out, so I'm going to get 1 over square root of 3 like that. Okay. So now, if I go through and do this, here's what you're going to look at. All right, now we know that the answer to this problem must fall within the range negative 90 to 90. Or in radians, it's going to have to fall from negative pi over 2 to pi over 2. Okay? Now, this is a positive value. So if you got a positive value, 1 over square root of 3, the only place that makes any sense for it to be is to be in quadrant 1. Okay? It can't be here or it can't be there because that's out of the specified range of answers on an inverse tangent. Okay? So what I'm going to do is I'm going to do this. I'm going to go ahead and just draw a picture of some sort in quadrant 1 and make a triangle like that. Okay, so we got y is 1, so that could be thought of as that side. Remember, this is y over x. The tangent's y over x, so that means x is square root of 3. Like that, and then r would be equal to 2. So that would force this to be a 30-degree angle like that. So that would be where that exists. So the answer to this problem would be 30 degrees. If you did that in radians, 30 degrees is the same thing as pi over 6 radians. Okay, so that's how you figure that out. It's all about the definitions. You have to know your definitions. You have to know the range of answers for each of these inverse trig functions. And then you got to know your triangles. And that's basically how that works out. This, to me, is the hardest problem area for students to learn in this section. Now, what I'm going to go ahead and do here is I'm going to go ahead and stop this recording here because I do want to do this recording in 2 parts. So you can review this, and hopefully this will help you understand this first part of the information in 1.5.